Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is flip-flops from sequential logic of digital logic circuits and design. On completion, the students will be able to understand the different types of flip-flops and also describe the characteristics equation and truth table of different flip-flops. Flip-flop. A flip-flop is a sequential digital electronic circuit that has two stable states that can be used to store a single bit of binary data. Flip-flops are the fundamental building blocks of all sort of memory devices. The common types of flip-flops are SR flip-flop, JK flip-flop, D flip-flop as well as T flip-flop. SR flip-flop. This is the simplest flip-flop circuit. It has a set input S and a reset input R. When S is set as active, the output Q would be high and Q bar will be low. If reset is set as active, then output Q is low and Q bar will be high. Once the outputs are established, the results of the circuit are maintained until the set or reset gets changed or the power is getting turned off. This is a logic diagram representing an SR flip-flop and its corresponding truth table for different values of set and reset, what will be the output and its corresponding states. And the characteristic table of a SR flip-flop with different combinations of the inputs S and R and the present state Q, so that we can determine the next state Q of T plus 1. And with respect to this characteristic table, we can obtain the algebraic equation for the next state Q of T plus 1. Similarly, we have JK flip-flop. Because of the invalid state corresponding to S equal to R equal to 1 in this previous SR flip-flop, there is a need for another flip-flop. So the JK flip-flop operates with only positive or negative clock transitions. The operation of the JK flip-flop is similar to the SR flip-flop, and here when the input J and K are different, then the output Q takes the value of J at the next clock edge. When input J and K are both low, then there is no change occurring at the output. And when input J and K are both high, then at the clock edge the output will toggle from one state to the other. So we can see the logic diagram of JK flip-flop and its corresponding truth table for different values of J and K and its output Q and its corresponding state, and the characteristics table being framed with J and K states and the present state Q, so that we can obtain the next state Q of T plus 1. The same characteristic table can be formulated into an algebraic equation. Quiz questions on flip-flops. What do you mean by a flip-flop? What are the different types of flip-flop? Write down the characteristics table of JK flip-flop. Draw the logic diagram of SR flip-flop. Thank you.